All right, for example 3 today, we're going to combine all of the transformations that we've learned so far into one function. So as you can see, we have the parent absolute value function on the graph on the left, and we are being asked to graph f of x equals 2 times the absolute value of x minus 4 minus 6. And so this actually has 3 different transformations. Starting in the front, we have a equals 2, which is going to cause a vertical stretch by a factor of 2. And then we have inside here, we have x minus 4, and that's going to be our letter C. And now remember, C is always going to take the opposite sign. So instead of actually being negative, C is going to be positive 4, and we are going to be going to the right. So it's a right shift 4 units. All right, so remember C is the opposite of what you see inside the absolute value. All right, so even though it's a minus 4, we're actually moving to the right because C is positive 4. And then in the back, which is what we learned about in the previous examples today, we have our letter D, and D always takes the same sign. So just C. C is the only one that is the opposite. So A and D, they both take whatever sign it looks like in the equation. So D equals negative 6. All right, and that is going to cause us to go down 6 units. All right, so this is a vertical shift down 6 units. All right, so if I have 3 transformations, what order do I go ahead and graph them in? Well, I find that the easiest way to graph them is to move the vertex left, right, up, and down before applying any vertical stretch. So the vertex of the parent function is at 0, 0. We are going to move it to the right 4 units and down 6 units. So 1, 2, 3, 4 units to the right and down 6. 1, 2, 3, 4, 5, 6. This is our new vertex. And now we have to apply the vertical stretch by a factor of 2. Now remember, the basic shape of the parent function has your vertex, and then it has a point on either side, simply over 1 and up 1. However, because we are stretching by a factor of 2, we're not going to go over 1 and up 1. All right, that is not what we're going to do. We are going to go over 1 and up 2 because that vertical distance has been stretched by a factor of 2. So that means now we know that these are straight lines, so that means basically our slope is 2. So we have, I'm just going to continue this, so up 2 over 1, up 2 over 1, right? I'm just going to draw out more points following that same pattern. All right, and now I'm going to do my best to draw my V. Notice how I'm extending my lines all the way to the end of the graph. Okay, I don't want to see any small v's. Let's make sure we're filling the entire graph. And this is the function for f of x equals 2 times the absolute value of x minus 4 minus 6. And just to make sure, let's go ahead and let's just check 2 of the points. Let's check the vertex, because you always want to check the vertex. So that's at 4, negative 6. And let's also check, let's see if I've done my pattern correctly. Well, let's just check this one here. Let's check 4, negative 4. All right, so first I'm going to start with the vertex. If I input 4, I should get negative 6. So I'm replacing x with 4. And then here I have to follow the order of operations. So first inside the bars. So 4 minus 4 is 0. Now I have to do the absolute value. So the absolute value of 0 is 0. So I'm going to have 2 times 0. So 2 times 0 is 0. Take away 6, we get negative 6. So just like our graph says, 4, negative 6 is our vertex, okay? All right, let's take a look at this other point, 4, negative 4. Wow, I just realized that can't both be 4, negative 4. I apologize. This is not a 4. This point is 5, negative 4. I'm having trouble reading my graphs. This is 5, comma, negative 4. So let's, excuse me, we can't, obviously they're not both an input of 4. That wouldn't make any sense. So let's input 5. F of 5 equals 2 times the absolute value of 5 minus 4 minus 6. So once again, we first do inside the absolute value. So that's 2 times the absolute value of 1. We do the absolute value. So the absolute value of 1 is just 1. Now we multiply. And now we subtract to get negative 4. And so just like the graph says, if I input a 5, I output a negative 4. All right, and once again, this part here where I'm just plugging in values, I'm just checking to make sure that I've graphed it correctly. Just taking a couple points off the graph and seeing if their input and output actually match the equation that I'm claiming that they match. All right, and so there you have it. There's how to graph using all 3 transformations.